Hi everyone. In this lecture, we will understand the different duty cycles being presented by the loads and accordingly which motor has to be selected and appropriate control strategy needs to be implemented. Also, we will see that the duty cycle or the drive cycle for electric vehicle or for let's suppose the any vehicle is the amalgamation of the many duty cycles. So we need to understand that all these different duty cycles to make a one EV drive cycle. So therefore, the controlling of the EV drives is very different from the controlling the other drives. So let's start. So here, this is the general block diagram of an electrical drive. So this we are talking about this kind of a load. The load running application that for as per the time that for how many long periods it is going to run. It is a short period, it is a long period, or it is the intermittent nature. So based on this load profile or load running profile, we need to select the motor accordingly, the best appropriate motor, and based on the selected motor we need to implement all the control strategy having the power modulator, the control unit, and the sensing unit. So first of all, we need to analyze the load profile, then only the rest of the things we need to take care of. So first we need to understand the different classification of the electrical drive. So we have individual drive, then we have the multi-motor drive, and then we have the group drives. So let's understand all these three drives with the schematic. Here we have the individual drive, which is simply one motor is driving my load, whereas the group drive is I have one motor over here which is driving my many load together. So one, two, three, here it is being shown that the three loads are being run by one a single motor. So this is kind of a group drive. Whereas my multi-motor drive is that many motors are coming together or is being used together to drive one load. So let's understand their practical applications. So as we know that the individual drive uh, can be used for the lathe machine, where the lathe machine can do all the works and can be run by a single motor. Similarly, the multi-motor drives were used to operate different parts of the machine. For example, a traveling crane uses three motors for hoisting, long travel, and the cross travel. So multi-motor drives are used in many applications like metal cutting machine tools, rolling machine, paper making machine, and aircrafts. Whereas the group drives, a single motor drives the main shaft, which is being shown over here in the schematic. Even though all the motors are not always required to work at the same time, however, this reduces the initial cost because of the diversity in the load. Means that a single motor of even 100 kilowatt is sufficient. So here we can understand that this is can be a picture of my electric vehicle where I have four motors on my all the four wheels. Similarly, this is also can be used or this can also be seen as one my EV application where only one motor can be on one motor is being used for driving my EV. So based on the presented requirement by the load, what are the factors which is being need to be considered to select an electrical drive or the electric motor? So here the number one is the steady state operation requirement. So at steady state, how the load is going to behave, what is its torque requirement, what will be the speed. So based on that, this is the one factor. The second is transient operation requirement. Let's say if some intermediate duty cycle has to be offered by the load, or let's say starting or braking is also happening just in the case of the electric vehicle. So the transient operation requirement, how it is going to be the offered by the load, so that also need to be taken care of. And the third is the requirement related to the source. What kind of a source is being there? Like in the case of EV, we have the battery energy sources. Uh, the fourth is the capital cost, running cost, and maintenance needs. All these factors need to be checked before implementing an electrical drive. and the space and the weight restriction also, because here this is again one more critical factor which is being very much I would say the important in case of the electric vehicle. Why? Because we have the space confined over there, and also we need to reduce the weight, because otherwise the efficiency of the overall EV will drop down. The sixth is the environment and the location, and the seventh is very of course the reliability. So based on the load requirement, the classes of the motor duty which is being presented by the load is being shown over in the 8 categories. So one is the continuous duty, the other one is the short duty, intermittent periodic duty, and the intermittent periodic duty with the starting. And the fifth is the intermittent periodic duty with the starting and breaking. So up to here, up to the fifth number, we can say that we will have the all the individual load cycles. We will see it. Then the sixth, seventh, and eighth, all these are nothing but the amalgamation or the combination of my first, fifth. So let's understand each of the duty cycle one by one. So here in this graph, we have the upper graph is related with the torque requirement by the load, and this is shows the temperature of my electrical drive implemented. So the how is the temperature is going to be the change or increase or decrease. So here for the continuous duty cycle, the it shows that my motor is or the load requirement is continuous, and it wants the constant torque from my motor. So here if I'm starting this, let's say my electrical drive from here, so the temperature is initially going to increase, and then it is going to be saturated because the motor is producing the constant torque and it is running continuously. So here it shows that electric motor temperature reaches the steady state value. So these motors are used in the paper meter drives, compressor or conveyors, etc. So the application like the compressor and the conveyors, they runs on the continuous duty cycle with constant torque requirement. The other duty cycle is the short time duty cycle. Here we can see that the load runs for a certain period of time or very short time, and then it is remain off. So as per this, the motor temperature reaches to certain value till by the time my load is in the on position or is running. Once it is going off, then motor temperature decreases and it is achieve the uh, cooling. So the on period is lesser than my off period. So if this is, let's say, the on period, then on period is lesser than my off period. So in that case, the motor achieves the ambient temperature. So these motors are used in the again the cane drives, household appliances, and valve drives where the torque requirement is only for the short time duty. The third is the intermittent periodic duty, and as the graph shows here, that load requires or load runs for the certain period of time, and then it goes off, then it comes into picture, then again it goes off. So in that case, motor achieves certain temperature, then it's cooled down to a certain value, then again it is achieves certain temperature, it is cooled down to again to a certain value. So this step is used in the press and the drilling machine. So drilling machine or the press where we need to drill something or we need to press something. So in that case, when the load is here, it is going to ask a torque requirement for my motor. Then when the drilling machine is not doing work, it is going to off. Then again it is drilling. Then again not. The fourth kind of the duty cycle is the intermittent periodic duty cycle with starting. So here, let's say the load has started and it requires the high starting torque. So compared to my the other starting torque requirement, other torque requirement by my load, the load requires here the more starting torque as compared to this reason. Similarly, when it is running, it goes on for the certain period of time with the starting, then it goes off for a small period of time, then again it starts, then again it has running torque requirement, and then again we are having this off period. So this we can understand that this is kind of a duty cycle where you can see that this can be correlated with the EVs, but it is not true. The EV runs for a certain period of time. Its speed also goes down, and its torque requirement is also goes up and down. So this is going to be the one part of my EV drive cycle. So the fifth kind of the duty cycle is the intermittent periodic duty with starting and the breaking. Here earlier we have seen that intermittent duty cycle with the early starting. Here we also have, instead of the starting, we also have the breaking where the torque requirement goes into the reverse direction. So this is something like that. Here we can have, or we are talking about the regenerative braking. So similarly, here we also have the torque requirement, which is opposite to my speed. So this is nothing but the braking period. And if we correlate with our four quadrant operation of the drives, then easily we can understand that this requires in the second quadrant, and this is and second and the fourth quadrant, and similarly this is also related with the second and fourth quadrant, based on that where my vehicle or where my EV is going, whether it is going in the forward direction or in the reverse direction. So based on all these five duty cycles, we can make the other duty cycles, remaining other duty cycles. But here we are more keen to understand the duty cycle or the drive cycle which is being presented by the EV. So here this is one example. It shows that the first one is the, let's say this is the my speed requirement. So the speed of the vehicle or the EV is different for the three reasons, in the three category. One, while I'm driving my EV in the city, while I'm driving my EV in the rural area, and while I'm driving my EV on the highways or the motorways. So here we can easily see that while driving the EVs in this city, we have the limited speed or the lower speed, and it is very frequent braking is also happening, and it is very much intermittent also in nature. So it is starting, stopping, starting and stopping, and also braking is also happening. Similarly, when I'm going for the rural areas or the outside of the city, then the speed goes slightly up, and the braking is also getting reduced. And while I'm going on the motorways, so it is something like the continuous duty cycle is happening over here, continuous duty cycle with a constant load on the highways. So taking over here again in terms of the torque, let's understand this graph. So again, this is showing the in the three category, the urban and the highway driving cycle, and the rural also will come into the picture over here. So here we can easily see that the torque requirement in the urban is slightly higher, because the speed is lower as compared to the highways. Sudden braking and starting is happening, so the torque requirement in the urban driving is very high compared to the highway driving, where my torque requirement something drops down as compared to my the city drive. However, the power which is required to run the EV on the highways remain constant, as here we have seen that the highways drive cycle is something like the constant speed. So the torque requirement goes down as compared to my urban drive cycle, and the power remains constant over here. Whereas in case of the urban drive cycle, here the power requirement is goes up, and torque requirement is also high. So therefore, the efficiency, or the, I would say, the fuel efficiency is lower in case of my uh, urban drive cycle, where the efficiency, fuel efficiency is higher in my highway drive cycle. And this shows that this is the base speed and this is the maximum speed where I'm going. If I'm going more than the maximum speed to give the optimized fuel efficiency. If I'm going beyond that, the power requirement by it goes down, and also very of course the torque requirement is also goes down. So this you can understand, actually this you can understand that this is going something like a downhill. So when I'm going downhill, the speed uh, increases, therefore due to the gravitational force the power requirement is reduces, the torque requirement is also reduces. So however, to stable the EV drive we have to apply the torque in the reverse direction. So this could be again a reason of the regeneration, not exactly, but if I'm going downhill then the regeneration can happen in this reason. So I hope we have understand that to make a EV drive cycle, it is not the one single cycle like the other loads requirement. Uh, Perhaps it is the amalgamation or the combination of the many duty cycles. It requires a different control in the city. It requires a different kind of a control in the or on the highways. So first we need to understand that how the drive cycle or the load requirement for EV is look like, and then only we can implement the required control strategies for it for the different areas like urban, rural, and highways. Thank you.